Well, this morning we had our first student pass out. I mean, passed out. Not like, oh, I don't feel good. Want to know what the picture was? It was the picture of a 15-year-old boy's back of his leg from about his top of his butt down to the thing, okay? Versus the boat's propeller.
Oh, so it got all cut up.
Oh.
Yeah.
Can we see it?
Was it a dude?
In what?
Was it a guy? Was it a girl?
It was a guy.
Oh.
And all of a sudden, so we're all sitting in. They're kids are sitting in shilling line. And I'm, you know, okay. Love you, man.
Did it hurt?
I was recording too, so it's already there. So all of a sudden you hear, ah! And you see these arms go up, and you see this dude just kind of like sitting in the shilling line. I'm like, oh, so I kind of helped her, lifted her, adjusted. And then once you pass out, once you start to wake up,
You still have the picture up, and she just like passed out.
She kind of freaked out a little bit, so it's just talking calm.
Can we see the picture?
No. Well, if you want to take the med class, yes. So, but it was good. It was real good. All right, so we're taking a look at the notes. We didn't get quite done with them, right? Let's flip those. Come on, baby. Flip. Let's see, how far did I get? I got to, there was like 6 problems on the page, right? There it is. That's where we got to. We got to right there, right? Okay, so these are one-step or solving a variable on one side. Okay? So you have these pages out. So our big problem is we want to get the variable by itself. This first particular problem here, this one here, we had that, right? So t is our variable. T is our unknown. It could stand for time. It could stand for anything. So what was the next step? I do a vertical line straight down, right? And then how do you think I would get this by itself? How can I move this over here? How can I move this over here? So that's plus 4. So what's going to undo plus 4?
Minus 4.
There you go. Oops, let's change colors on that. Minus 4. So subtract 4 for both sides. So that gives me negative 3 over here equals t over 3. And then t over 3 is a division problem, right? So how do I undo division? Yeah, so I'll multiply this by 3, this by 3. And I find that's what t is equal to. That make sense? We're going on number 5 down here. What's taking place with this whole problem right here? What is x minus 3 all on top? The whole thing a numerator. It's x minus 3 a numerator to the entire fraction. Is it? Got a question out there? Is x minus 3 a numerator?
Yeah.
Thank you. I want to leave x minus 3 alone right now. X minus 3 is divided by 7. What should I do to both sides on number 5? What should I do to both sides on that problem? 7's on bottom, so what should I do with it to move it to the right side? Thank you. I'm going to multiply here and here. If I do multiply, this is going to cancel this and this. It leaves me x minus 3. And then what's 7 times 12? 84? How do I get x by itself right here? Plus 3, thank you. I go ahead and solve that x is equal to 87. All right? I'm going to move out this page. I'm not worried. I don't have number 6 down. We'll see some more. We have a place called Yummy Yogurt. I have no idea if it's a real place or not. It's probably just something fictitious. But it says you paid 35 cents for the container and then 40 cents per ounce for yogurt and toppings. You bought $4.75 worth of this yogurt. You went up there. So part of that price was the 35 cents, which was the cup, right? Make sense? But then the yogurt's going to cost us 40 cents for every ounce. And I'm not going to use O for a variable because it's O. So that's our situation. So now that, if you just walk into the yogurt place and said, hey, can I just have a cup? They're going to charge you 35 cents. That's empty. But then it's your choice if you want to go fill it up with yogurt, and they're going to weigh it and then say, okay, now you've got this many ounces of yogurt, and you're going to pay a little bit extra plus the 35 cents. All right, so how should I start solving this equation? Thoughts? Subtract what?
0.35.
Awesome. Subtract 0.35 from both sides. Why am I not changing colors? So I'm going to subtract 0.35 from both sides. That's going to cancel, so that leaves me 0.4z, and z represents ounces. Okay? If I do this subtraction, 475 subtracting 475 minus 0.35, I should get 4.40. So that you paid $4.40 worth of yogurt, and you know that the yogurt was 40 cents per ounce. So I'd say you got, oops, 140, sorry. So you're going to find that you're going to go 1 over the other, which basically comes out to 44 over 4. So it looks like you have 11 ounces of yogurt that you purchased. Is 11 ounces of yogurt a lot of yogurt? I don't know. I mean, a can of soda is a 12-ounce can, right? So 11 ounces of soda is a little bit smaller than a 12-ounce can of soda, or 11 ounces of yogurt would be a little bit smaller than a can of soda. I don't know, decent amount. When I go to those yogurt places, I always get up there and it's like, okay, sir, it's $11.40. Dang, I got a lot of yogurt, right? All right. So that was yesterday's notes. Yes? All right. I'm going to knock this one off, and I'm not going to save those. Then I can find, where'd you go? The new smart class. All right. So I have some notes for us. Neat. Those of you that are taking the pre-test, you doing okay? Yeah. Now we're going to have a variable on both sides. The fortunate thing is our variable is still going to remain to be a single variable. We're not going to have multiple variables with the equation. All right? So this one says, we're warming up. You have a cell phone bill this month was $59.40. You have a monthly service charge of $30 and your plan costs 7 cents per minute. How many minutes did you talk on the cell phone? So I know a lot of the service plans now for cell phones, you just pay a flat fee unless you go over your certain amount of data usage, right? But I imagine there might be a plan that's still out there. So, what is your total bill? What's your total bill? What's this total bill? $59.40. Okay. How much do you pay per month, regardless if you use your cell phone or not? $30. And then we're paying this 0.07 M for minute. Does that work? If you use your phone or not, you still have to pay the $30 in order to keep your phone number active. So from here, I could make a dotted line, subtract 30 from both sides. 0.07 M equals $29.40. You did $29.40 worth of ringing up your bills because you spoke on the phone. How am I going to get M by itself? Divide side by 0.07. Does anybody have a calculator with them by chance? And if so, would you go 29.4 divided by 0.07? There's a lot of buttons. Does anybody have a calculator? I see one.
Mine's not set up.
Go on, grab one.
Someone's already on.
Do we have an answer yet?
What is the question?
It's the same one that's posted on the board, 29.4 divided by 0.07. So 29.4. How much?
Divided by
0.07.
420.
Really? It's 420 minutes?
Yes.
Sweet. So we spoke on our phone for 420 minutes last. Oh, that's what it was. Yeah, you said 42, huh? Cool. Good deal. All right. Not too bad, was it? To solve an equation, our goal is to isolate the variable, which in cheap terms means get letter alone. All right? Don't worry, I teach the math class. They said it's okay. Moving on, is that okay?
Yes.
All right. Think of these as a balance beam. So you remember I continue to draw this nice dotted line straight down, right? So what you do to the left side, you have to do to the right side. What you do to the right side, you have to do to the left side. If you add something to the left side, you have to add it to the right side. If you multiply something to the right side, you have to do it to the left. If you multiply by reciprocals on one side, you have to do the reciprocal to the other side. That's a flip over of a fraction. Okay? So what you do to one side, you have to do the other, and this is a balance. So if you had 10 over here, you have to have 10 over here, and it stays balanced. All right? Let's see if we can walk through this. Item number 1. Let's get over the anxiety that our letter always has to be on the left side. I don't always have to have x equals. I can have a number equals x. It means the same thing. Is that okay? That's the first thing I want to address. Are we okay with that? Now, I have no problem if you're always trying to get x on the same side, but I think sometimes people get hung up that the letter always has to be on the left side, and it might goof up their problem. What would happen if I did this to both sides? What happens if I do that to both sides? What do I have? Go ahead.
It's 3, it'd be 3 equals
Right.
2x minus 21.
Good. 3 equals 2x minus 21. Okay? So the x, it's okay to have the variable on the right side. You didn't break something. When you get a teacher who gets the anxiety that's, oh, so what's going to be on the left? It's like, what should I do to start getting x by itself? I'm going to leave it on the right side now. I'm happy with it over there. What's my next step? Go ahead.
You add 21 on each side.
Yeah, I'm going to add 21 to both sides. So on this side, I'm going to have 24. On this side, I'm going to have 2x. How do I undo 2x?
Divide it.
Divide by 2. So this and this cancel. And that allows me to say that x is equal to, what's 24 over 2?
12.
12. There's my answer. Done. Is that okay? Problem number 2. We're using the variable d. I would like to get d to move over. So is this the same thing as 1d? So I'm going to subtract 1d from this side. I'm going to subtract 1d from this side. So negative 7d, right? So I have negative 7d over here, and that's equal to 4, positive 4. What should I divide both sides by to get d all by itself? I heard it. Negative 7, perfect. Divide both sides by negative 7. So I wind up with d is equal to, oh, is it okay if our letter equals a fraction? Sure. That worked. How we doing? We doing all right? How you doing? Like that's funny.
What if
Okay. You want to ask? You can. I need somebody to talk me through this. First step, very first step.
Oh, put the line in the middle.
What does that line represent?
Dividing.
Equal. And I'll do the line here too, so we're going to do these two problems. Everyone feel comfortable with what we just did? All right, looking at problem number 3, I need to get m on either the right side or the left side. So we have to kind of choose what we want to do. You want to move it the 3m over to have 0 on the right side, or do you want to move the m over to be on the left side, have left negative 5? What do you think? So move the m. So I'm subtracting 1m from both sides. So I get negative 5 is equal to 2m. All right. Divide each side by 2. So I find that my answer is 5 over 2. We can leave it just like that. We don't have to change it to a mixed number. Okay? Problem number 4. I want to solve for k. So let's think about how we want to move the variable over first. Should we subtract 7k from both sides to bring it to the right side? Or should we subtract 5k from both sides to bring it to the left side? Go ahead. I like that. Okay, I'll take the 5k. Now, some people might be thinking, well, I want to have it on the other side. Your answer's still the same. So 7k subtracting 5k is 2k. Minus 4 equals, these cancel. So what am I left with over here? What's on this side? 16. Good. And it's positive 16. Do I have to put plus 16? No, because if it's just 16, you know it's positive. What seems like a good move now to start getting k by itself? Yeah, add 4. I love it. Add a 4. I have 2k is equal to 20. Last step, 2 and k are being held together by multiplication. How do you undo that?
divide by 2?
Divide by 2. Done. Have one more slide? Is that right? All right, problem number 5. We know our first step is going to be to do this, so I'll do this to both of these. Is that okay? That represents our equal sign. Problem number 5. Would you like to, let's take care of the variable first. So should we add 8a to both sides, or should we subtract or add 4a to both sides? It's your choice.
Add 8A.
Add 8a, okay. The nice thing by you doing that, now we don't have a negative variable. So I have a 10 still over here. I have a 5 minus 4a, or excuse me, plus 4a over here. What should I do next? I still want to get this by itself. Subtract 5, good. So I get 4a is equal to 5. Last step. Divide by 4. Good. And again, I can keep it as a mixed or an improper fraction, meaning the top's bigger than the bottom. So a is equal to 5/4. Okay? I think I'll look at number 6. Before we start moving things back and forth, is there anything that's happening on the right side of the problem? Yeah,
There's a, so 7 plus 7 minus 10.
right. So those are like terms.
Yeah.
I'm going to go ahead and combine those first. 7m, subtract that, is going to be 6m, and then plus 7. All right? Let's take care of the m's from both sides. So I'm going to subtract 6m, subtract 6m, subtract 6m. So that cancels. So that gives me negative 5 over here. And that cancels. So that gives me, whoa. Did you all know that negative 5 is really equal to 7? Or is that nonsense? Like, did we just discover some math anomaly that no one ever knew? Maybe we did. Yeah. What do you think?
Wouldn't you just add 1m to all of the m's to get rid of that little negative one and then start trying to isolate the variable?
So you added this and this? Is that
Yeah, and to the 6m. Right?
Oh, so
Would you
what
do
you
that
do
or
is you
no?
want to take care of it because it's on the same side.
Oh,
So you combine it on the same side, and then you start moving things back and forth.
would you do that?
What do you got? Yeah. So this is no solution. And once you're like, loving math, we actually use this. You have these fancy brackets, and you have a 0 with a vertical slash through it, which actually means empty set. But as of right now, totally fine with the no solution. Totally fine. How do we all feel? It is Friday, right? So let's go ahead and get a start on the assignment tonight.
Oh,
Sorry. Get your break last night. I know. We're not Grandview. We don't just give you time off. All right. Your assignment.
Wait, what do you mean by Grandview gives you time off?
It's a rival school. I like ripping on them.
I almost went to Grandview. They have a better wrestling program.
I'm going to Grandview.
I'm following you.
All right. Page 5 and 6 is your homework. Remember, some of you might not have your book yet. Just by a show of hands, who does not pick up the textbook yet? I got 1. You know where to get it? Okay. And you know where to get it? Okay. So I think you have enough. I think I have the sheet for at least tonight, maybe Mondays. But after that, you're on your own, okay?
Is this out of the packet or is this out of the book?
It's out of that the book. But it could be the packet if you have the packet still. It's up to you, whatever you want to get it. Sweet.
5 and 6.